Okay, let me get going on this, guys, because it's a pretty long lesson, so I want to get through this. So remember, at any point, if you need to pause or rewind, go ahead and do that to make sure that you hear and get all of the notes. So if I talk a little fast, I'm sorry, but I got to get this in. All right, first thing I want to talk about in our simplifying variable expressions, which is what this lesson is on, is I want to go over some definitions. Now, I'm not going to have you write down the definitions, but I do want to have you go over them so you know what I'm talking about. You do need to know these words, so make sure you understand what they are. The first thing I want to talk about is terms. And terms are the parts that make up an expression. And we have three terms in this example. They're 5x, 4x, and 7. And the terms are separated by addition or subtraction symbols. So a plus sign or minus sign is going to separate our terms. That's how we're going to look for. Multiplying and dividing does not separate terms. The next thing I want to talk about, staying with our terms, is our like terms. And we have 4x and 5x, and they're called like terms. And like terms are terms that have identical variables in them, or just numbers that don't have variables. So like 7 and 11 would be like terms. And the 5x and 4x are like because they have identical variables. Now, if we had a squared in there, like 5x squared or 4x and 4x, that would not work because one has a squared and one does not. All right, next term I want to talk about is coefficients. And coefficients are numbers that are being multiplied to a variable. Coefficients. Okay, and so for a shortcut, I always say the number that's in front of a variable, but is the number that's being multiplied to a variable. That is a coefficient. So the 5 is a coefficient and the 4. Not the whole thing, just the number. 5 is a coefficient of 5x, 4 is a coefficient of 4. And the last definition I want to talk about is called a constant. And a constant is a number that does not have a variable, and it's just a number. That's why it's a constant. It never changes. It is always, an example, this one is always 7. It never changes. Okay, I'm going to change the slide, so if you're not done copying that down, make sure you copy it down. Here's our next slide. In our next slide, I want to talk about identifying parts of an expression. So terms, like terms, coefficients, and constants are the words that I just went over. So I want to make sure that you guys know what they are and can identify them, and this is going to be very important. Now, one of the things I want to do is when we talked about commutative property and associative property, it only worked with adding and multiplying. Well, I'm not going to worry about multiplying right now, but I do have to think about that adding because that's going to come up all the time. So if I have in my problem here negative 13c minus 4 minus 5c minus 6, I always have to think of those as addition problems. So what do I need to do to make them addition? Well, I need to make the minus a plus and then make the number negative. And this is something that I'm going to show you and I'm going to write on the first couple of problems, but some of you would just do in your head. And you have to remember these, but I encourage you to write them down to help you with them. So my terms of this, I have 4 terms in this problem. I have the 13c, and I'm just going to list them. I have the negative 4, so it's not minus 4. That minus 4 means negative 4. Okay, minus 4 and plus negative, same thing, so you have to account for that. Negative 4, negative 5c, and negative 6. Those are my terms. I have 4 terms. What's separated by my plus or minus signs? My next I want to talk about like terms. Now in this case I have 2 sets of like terms. I have the 13c and the negative 5c. So that's one term, one set. 13c and negative 5c. My other set are the constants. I have negative 4 and negative 6. So that's another set. Sometimes you only have one set, sometimes you have no sets, sometimes you have multiple sets. In this case, we have 2. Now, coefficients, remember the numbers that are being multiplied by a variable. So that's 13 is in front of the c, being multiplied to the c, and negative 5 is being multiplied to the c. So those are my 2 coefficients. I also have 2 constants, and my 2 constants are negative 4 and negative 6. And again, I want to do that plus negative early in the problem because then when I have it again, I don't forget to keep those all negative. Otherwise, a lot of you are going to make them positive, and that is wrong. Okay, if you need to pause, go ahead and pause. Otherwise, I'm going to flip the screen. In our next example, simplifying the expression, what you are going to do here is basically, this is called combining like terms. So we have to identify our like terms, and then we're going to simplify them by combining them, adding them, or subtracting them. I always like to start with the variable, and so just to keep things consistent, put the variable first as the first term, and then that way we don't have to worry about too many parts when trying to grade them, because there are lots of ways of writing these. So for my first example, I'm going to start with my variables, and the first one I'm going to show you by doing a plus negative. So I'm going to make this plus negative 9 plus negative 7. Again, I want to remember, I am using the associative and commutative property to do these, so they have to be addition problems. Now, I'm not going to make you rewrite them, but you do need to know that's happening, so that's why we have to make them addition. Now I can combine the terms. So I'm going to start with my variables, so I'm going to do the 12x and then plus negative 7x. And I'm going to do that work. 12k, I'm sorry, those are k's. 12k plus negative 7k is 5k. So I'm going to do 5k. Now I'm going to work with my constants. I have a negative 9 and I have a 20. Okay, so negative 9 plus 20 is positive 11. So that's 5k plus 11. And that is my final answer. Again, I cannot combine the 5k and the 11 because they are not like terms. I can only combine like terms. So that's my final answer. Similar to distributive property that we had last night. Okay, in the next one, I want to talk about a different property. We talked about the identity property, which said anything times 1 was itself. Well, that works in the opposite. Anything by itself, like a w, really means 1w. So as you're learning, you might want to put a 1 in front of the variables that are by themselves so you know what the constant is. And that does have a constant of 1 even though it's not written. And you need to remember that in identifying and in this. Now in this one I'm not going to make plus negative, and I'm going to show you how you can do it without having to rewrite it. Although you can do it that way. I'm going to start with my variables first. I'm going to use the operation goes in front of the term. So it's a plus 8w and then minus 1w. So the operation goes in front of the term. It's not term operation, it's operation and then the term. So I can do that work. 8w minus 1w, 7w. Now I'm going to work with my constants. I have a 5 and I have a minus 6. 5 minus 6 is negative 1, so negative 1. 7w minus 1. Okay, remember minus 1, or I could write that as 7w plus negative 1. That's the same thing. Okay, doesn't matter. I give you credit for either way. Okay, if you need to finish writing that down, write that down. Otherwise, I'm going to go to my next screen. In our next screen, we have simplifying expressions with parentheses. So in these examples, I first must do the distributive property that we worked on the other day. So in the first example, I have to distribute first. 5 times 6 is 30, plus 5 times b is 5b, plus 4b, minus 9. Yes, you must rewrite the entire problem. You do have to show this step. Then I'm going to combine. Okay, I got my 5b plus 5b plus 4b, so that's 9b. I have a 30 minus 9, that's 21, so plus 21. 9b plus 21. That's my final answer. B is a tricky one because I have this minus 3 here in front of the parentheses. I do not distribute a 3 to both numbers. That would be wrong. I have to distribute a minus 3 to both. So to remind me, I am going to make this one plus negative 3. To remind me that I'm distributing a negative 3 to each number. So then I'm going to rewrite. So I'm going to get 4m plus 12 plus negative 3 times 2 is negative 6m plus negative 3 times 2 is negative 6. Now I can combine like terms. 4m plus negative 6m is negative 2m. Constants, positive 12 plus negative 6 is, well, they're different signs, so you subtract them. I have 12 is bigger than 6, it's positive, so it's going to be negative 2m plus 6. That's going to be my final answer for that. So that's how you do those. You distribute first, then simplify. You have to distribute first, then simplify. If you have a minus constant in front of your distributive property, that is a negative that you have to distribute, so you make sure you do that. Okay, I'm going to go to my next slide, so if you need to pause, go ahead. Okay, in our final example, which takes 2 slides, we are going to write an expression, and you guys need to really work on these, and we're going to spend some time. Okay, here's my question. During your workout, you spend a total of 45 minutes jogging and swimming. You burn 14 calories per minute when jogging, 8 calories per minute when swimming.
Natalie Harding, get out to your bus right away. Natalie Harding, Mom's waiting.
Okay, we had a nice interruption there.
Not your bus, your car ride.
Okay, we had another nice interruption. You burn 14 calories per minute when jogging and 8 calories per minute when swimming. Write and simplify an expression letting J represent your time you jog. So when I write this one, I want to know how much time, or how much calories I'm burning. That's what my problem is going to be about. So let's write an expression, and we're going to use J for time you jog. So the easy one is the jogging one, 14 calories per jogging. That's just going to be 14J. I'm going to slide this down a little bit so I can see. Now the next one is going to be the swimming. I can't just do plus 8 times my swimming, S, because I have to think of my jogging. So what I have to think of is what is left in my jogging time. How much time am I jogging? Well, since I went a total of 45 minutes, it's going to be 45 minus the time I jogged. If I jog for 10 minutes, it's going to be 45 minus 10, which is 35. If I jog for 25 minutes, it's going to be 45 minus 25, or 20. So it's going to be 8 times the remaining time. That's 45 minus J. Now I can simplify that by distributing first, so that's going to be 14J plus 8 times 45 is going to be 360 minus 8J. Then I can combine like terms, 14J minus 8J, that's 6J plus 360. Okay, so that's my expression. Now if I gave you an amount of time that you jogged, you could figure out the answer, which is what I'm going to do in my next slide. So if you need to pause, go ahead and pause. Okay, my final slide here, I'm going to write down that expression again so that we remember. You probably don't need to rewrite it because it's at the top of your notes there. Now I want to do if I jog for 20 minutes. So I'm going to plug 20 in for J. I do 6 times 20 plus 360. That is 120 plus 360. Add those together, that's 480. And this is a word problem, so I need a unit, 480 calories. And that is how I write and solve those equations. Okay, have a good night, and make sure that you guys look over and can combine the like terms and pay attention to the minuses or plus negatives. That stuff is very important. Have a good night, and we'll see you tomorrow.